All right, we have continued. So we prove this for the right hand side of the equation. Remember, this gray line is the right hand side of the equation. That place where let me change this to gray is the right hand side of the equation. So now let's do it for the left hand side of the equation. If this equation is true, all right, left is equals to right is an equation. It means that if the left hand side, oh sorry, the gray part is the left hand side, the blue part is the right hand side. If this equation is true, it means that the inequality should still hold for the blue side. It means that we should also be able to put the blue side and the equation should be true. So let's try that. So let me just write the right hand side again. A plus b f, okay. um a plus b oh, a plus b f of a squared plus b squared. All right, so this is what we have now. So let's make some comparisons with the initial inequality. This here in the black box is the initial inequality. Let's make some comparisons. Let me expand the blue part. If you expand it, it's going to become a f of a squared plus b squared plus b or okay, let me just expand. I don't think we should expand it because I was just looking at the inequality again and I saw that we can just cancel things out. All right. So if you are making some comparisons, if you are making some comparisons, we'll do where is it? The black part. So let me just like write this. Let me do this. A f of a plus b f of b plus b f of a is less than the blue part now. A plus b f of a squared plus b squared. Then a f of b plus b f of b. So this one I just wrote now is an assumption. I don't know whether it holds. It may hold, it may not hold. But let's just see what we can do from here. We can factorize the red part and the green part. So if we factorize the red part and the green part, we get a plus b f of a is less than a lot of writing. Alright, so we can just cancel some things out. Cancel, and now we are left with this f of a, something much shorter. Finally, something much shorter for me to write. Oh my god. Oh, okay. For some reason, the laptop was lagging for some reason I don't understand. And all right. So this is the inequality. So f of a, let's say f of a is something. F of b is something. But the issue with this inequality is that it cannot always hold true. Unlike this one that we had here, this where was it? Unlike this one here that we had, we are sure that this inequality is true. But this one here that we have now, this new one that we have here, this yellow line, we are not always sure that it hold true. Because if it's a non constant function, we can have a situation where f of b is 4, then a f of a is 2. Then we can say f of a squared plus b squared. Let's say some sort of weird equation. F of a squared plus b squared, a squared plus b squared can give us 3. But what if we have a situation where we have for the same function, we have, remember, our input is positive integers, natural numbers, and our output is also natural numbers. Like, look at it, input natural, output natural. That means we cannot have decimal in between. We cannot have decimal at any point. But if we have a situation where we have this f of b is equals to 3. Oh my god, I didn't write that properly. Yeah, and f of a is equals to 2. What can f of a squared plus b squared be if our answer must be an integer and it is less than, remember, it is not less than or equals to, it is less than. There is nothing f of a squared plus b squared cannot exist if we have a situation like this. That means this equation cannot hold, this inequality on yellow here cannot hold true. And if this inequality cannot hold true, but this one here, but if this one is holding true and the one on yellow cannot hold true, and is an equation, it means that that equation cannot hold true for non-constant value. That means our only function is f of x is equals to a constant. That's our only function. So, and one more thing, okay, sorry, in the previous video, I remember I said something like this: f of x is equals to k, and I was saying that k can be a negative value. But k can be a negative value because I forgot. I just realized that our input is natural number and our output has to be natural numbers, and a negative value is not a natural number, so k can only be positive. And that wraps it up. Hope you understood.